So today we will cover about the derived data type. Actually, Fortran support many types of data types, such kind of integer, floating point variable, like a character, many types. We already studied this. However, in real world, it's much more complex to represent all things using those variables. Such kind of, let's think about, the human name can be represented by character. Yes, that is correct. However, thing is, what about the human? If I would like to introduce some variables, such kind of human, it is not straightforward. There are lots of properties. First of all, name, maybe gender, or height. There are many properties of the human. Okay, so it is not straightforward to represent those all properties using one or two variables. Okay, that's why we would like to derive some data type. Okay, actually, if we really want to represent the variables which can declare the variables which can represent the real things more actively or more efficiently, derived data types can be very good way. Let's think about the variable book. Okay, then what is the property of the book? First of all, it can be name, book title, author will be there, also like a year published, or maybe if the book is included in the library, maybe there are some book ID. Okay, so those things are all properties of book. And if we can handle those variables in one container, that is much more efficient. Okay, so that's why we would like to introduce the form of the derived data type. Okay, so let's take a look here. Okay, here is the directive which I would like to derive some data type. Their data type is books. Okay, first the characteristics, title, another characteristic, subject, author, another characteristic, subject, and maybe this book have the ID. Okay, ID number can be integer. Here is the data type books. Okay, then how can we declare the variable which data type is books? Means type embrace books colon book 1. Okay, so here I declare one variable which their data type is books, another variable book 2 which their data type is books also. Okay, so now I declare two books. Okay, and their properties will be title, author, subject. Okay. Okay, and how can you access those properties? The directive we need is percentile. Percentile directive means book 1 percentile title means title variable of the book 1. Okay, so title of the book 1 is 훈민정음, which is a kind of very old classic, which they explain about how can we invent the Korean characters and what's the reason we developed the Korean characters. Those kind of that things are included in this book. The author is ancient King Sejong. Okay, subject new and native script of Korean language, and book ID can be 1. Okay, another book. Let's think about the Hamlet. Okay, it is also one classic of the English literature. So the tragedy of Hamlet, Prince of Denmark. Book author is William Shakespeare. Subject play Tempest, Prince Hamlet and his revenge. And second, the ID is the second. Okay. So in that cases, we can declare those variables as like this. Then I would like to console out. That is possible. So book 1, book 2, that is possible. So run it. Okay, so book title is 훈민정음, book author is King Sejong, subject is new and native script of Korean language, book ID is 1. And another book is can be there. If we do not drive those things, maybe we can declare, let's say, think about maybe that way is possible. Title 2, title 3, maybe that way is possible. However, it's much more inefficient. Okay, much more inefficient. So if we make it contain those values in one, like a container, let's think about the drive data type books. It's much more intuitive and much more efficient. Okay, here is the example for the drive data type. Okay, then we would like to use it. Let's move on to another example. Okay, so we would like to introduce another type of data type, another data type, linked list. It's a kind of data structure. We have roundabout array. Then what is array? So let's think about A10 array. It means first component, first, second, third, fourth, 10th component. So we can access those variables easily. However, the problem is insert or delete is not really simple. Okay, insert or delete is not simple. Let's think about only A4. So here is, let's assume 1, 3, maybe 2, and 4. How can we delete those variables? How can we remove those variables? That is not simple. First of all, we would like to copy those variables first, and then remove it, and then move it to there. That's what we usually do to delete the variable in array. Actually, if it is relatively short, okay, it is fine. However, let's assume it is like length of the array is like think about 200, then it is not really easy thing, okay? Because we have to move all those things to there. The only thing we did is just remove one element. However, migrating all elements to there is not really easy thing, and it is very not efficient. Another way is add one variable is also not easy. Okay, let's think of 1, 3, 2, 4, and there are other followings. What if we would like to add variable there? Like let's think about 5 there. Then first of all, we have to copy all of them, and we added that like a 5 to here, and then copy to there. Okay. So removing and inserting is not really straightforward, and it is not really easy, okay, for array. So there are another data type which can improve those characters, like such the data type which make us the inserting or deleting much easier. So in that cases, we say it is linked list. Linked list is the data type. Let's think about the train. Okay, here there are some variables, and there's also pointer which indicate the following nodes. Okay, so we say it is node. Nodes have their data and pointer. Okay, so another nodes is here 3 point. Let's think about 2 points. Let's that way. So if we would like to add one variable, one node, let's think of in the red color, I would like to say 5. then only thing we do need to do is indicate those nodes to here and those nodes indicate there. That's it. That's it. Only two pointing can add one node to the total list. We say it is linked list. That's why it is really convenient. Or removing. If I would like to remove those nodes, the only thing we need to do is, first of all, originally it indicates to that node, just change the point to indicate this node. Okay, this node that allow us to remove this node. Okay, so it is very, very important, very, very easy, and we do not need to rearrange the memory, so it's much more efficient. So that's why in terms of inserting or removing node, the linked list is much more efficient. Here, in the linked list, first of all, we do need head node. We do need head node. First node have to be head, and linked list, we always need head. Okay, head, tailing node, tailing node, tailing node. There are only one-way connection, so we say it is singly linked list. Singly linked list means there are only one-way connection. Okay, if there are two-way connections, let's think about like here and here, then we say it is doubly connected. However, we do not neglect those types of connections, so we say it is singly linked list. Okay, singly linked list. Here, we would like to introduce some derived data type. Let's think about the list module. List has their variable, which type is floating point variable, and we do need pointer, which indicate the next node, and their data type is pointer of themselves. Okay, because let's think about first node indicate another node. So another node means we have to indicate a pointer of list module, because the node data type here is derived by the list module. So we do need pointer of the list element. Okay, list element. So here is a data type here. So inside the module, there is a member of the element, and we do need the from floating point variable and pointer for the tailing tailing node. Okay, tailing node. 자, 무엇을 얘기하는 거냐면, 자, 원래 지금 이것을 struct 구조체라고 하면, 자, 여기서 이 listLM이라는 구조체 내에는 floating point variable과 그 다음 구조체를 가리키는 포인터가 포함되어 있습니다. 그래서 그 포인터가 여기에 포함되어 있는데, 각각의 구조체는 그 어떤 floating point variable 하나와 그 다음 노드를 가리키는 포인터를 여기에 동시에 포함하고 있는 겁니다. 그러면 이것을 통해서 우리가 하나의 linked list의 하나의 노드를 선언할 수 있습니다. Okay, so first of all, we didn't pointer indicate the head node. Okay, head node, and the list is while the point is associated, then we would like to print the value, print and their value, and then we have to access the next node. The linked list, singly linked list, let's think about the only way we can access the third node is, first of all, the only thing we have is the pointer of the head. Okay, pointer of head. That is head node, and then next over head node, and then next over head node. So that's how we can access there. And that is inefficiency. Such kind of, for the array, we can directly access here. However, for the linked list, we cannot directly access there. The only way we can access for the singly linked list is we have only pointer of the head. So we do need access the next of the pointer node and next of the pointer node. Okay, so we do need those work to access here, and that is in the disadvantage comparing to the array. Okay, so here is the thing. First of all, we start from head, and then do while pointer is associated, we print out the value of those node, and then printer will indicate the next of the printer node. Okay, next of the printer node. So what is the next? Next means the pointer indicate the next node, so we say that is represented by the value next here. And okay, insert node. First of all, okay, so I would like to see this example. Okay, first of all, there is interface. So there are three subroutines: print list, insert list, delete list. There are actually three main functionalities: print, insert, delete. Okay, so first of all, I would like to see those interface first, and then first of all, I have to nullify the head pointer. So there's nothing with the head, okay? Head indicates nothing, head point nothing. First of all, we have to allocate a new element, okay? New element. Generate a random number, and that is the value of the new element value. So value is included in the new element. Okay, insert list. So far the head is null, okay? So head is null, and I put the new element, okay? So go to the insert list, go to the insert list, then here is the insert list. So ln next node have to be head, and insert node point ln, okay? Ln next node is head, and insert list indicate ln. So after doing this, new ln, if what think about it. So let's think about it. If there is head, current head, and now next node like this. If I would like to insert some new element, then like let's say it is ln, okay, ln, and ln next to be have to be head, okay? So still the head is here and ln is here, okay? From this comment, ln next node is head, and insert node becomes indicate ln. So insert node indicate ln. So now insert node indicate ln, okay? Now insert node indicate ln, and what's the following result? Here, so this line is pretty important. Head indicate the insert node, okay? So it will be represented by head, okay? So now it becomes head, and it is not head any longer, okay? It is not head any longer. So if new element is added, then new coming element have to be head, and it becomes the next node of the head. So the previous head becomes next node of the head, and new element will be head. Okay, so it is previous head. Okay, so new added element will be always headed in this code. Okay, element have to be head in this code. And print node, print list. So let's think about the print list. So here is the print list. So first of all, variable pointer indicate the head, Pointer indicate the head, and the wrist is while the pointer is associated, console out value of the pointer, and pointer indicate the next of the current pointer. So it means from the head, next, so far on. So pointer has some value. First of all, console out the value, and pointer indicate the next of the pointer. So this node. Okay, this node is still associated. Console out the value and indicate the next node. Console out the value and indicate the next node. Console out the value and indicate the node. If this node is the last node, then pointer is not associated any longer. So it will exit the do while loop. Okay, it will exit the do while loop. What about the delete? Delete node is assume the head is associated, then H, so let's think about H indicate the head, and here, H indicate the head. First of all, we do need some auxiliary pointer here to indicate the head, and then head, there's another pointer large H, okay? It indicates a head, okay? It is not head, it's like H only. So we do need additional pointer to access there. I would like to introduce the reason. In this line, we indicate the next of the head to the head, okay? So if we change this, then the problem is if we do not have this pointer, there is no way to access this node. So we cannot delete it. That is the problem. The only thing, so far, we have the large H pointer here, so it means it is head. However, if we H indicate the next node of the head, then at that moment, there is no way to access the current node. So that's why the flipping the point, before the flipping the point, we introduce additional pointer to indicate this. Let's think about the small h, okay? Okay, it indicated. And now the pointer flip to point out the next node. So it does not point the head node here. However, still we cannot delete it because we have additional point h here, okay? So it is very important. If we do not have those types of small h pointer here, then we cannot delete this previous head node, okay? And then now the situation here, also the small h node indicate here, so we can delete all node until head is associated, okay? Until head is associated. That's how we delete it. So run it. Okay, first of all, the wrist is, let's assume the value is given by here. New node have to be head, so head and next node. New node is coming, so there are 3 nodes, 4 nodes, okay, 4 nodes. And once we delete it, then first thing we have to delete is this node. The sequential have to be, first of all, we have to delete the head node, another node, another node, another node. That's how we delete the node, okay? So this is a kind of linked list, and it is very efficient in terms of inserting and deleting. 자, linked list가 배열에 비해서 효과적인 이유는, 자, 이렇게 삽입과 제거가 쉽기 때문입니다. 반면에 비효율적인 이유는 전반적으로 배열을 훨씬 많이 쓰는 이유는 액세스가 불편해요. 액세스가 예를 들어서 이 3번째 노드에 접근하려면 이걸 통해서 이렇게 접근하는 수밖에 없습니다. 이게 불편해요. 배열이라면 그냥 이렇게 바로 한 방에 접근할 수 있죠. 이게 편한 겁니다. The convenience of array is very strong because we can access the third element by this way. However, for the linked list, we have to access the third node sequentially. First of all, we have to access the head, and then next of the head, and next of the head. That's the only way we can access the third node in singly linked list. Okay, so today we study about the singly linked list. Is think about this kind of like a train, okay, train, kind of there are head train, and next content of the head, next content of the head, next content of the head, and we assume that there is only one gate in the head, so people would like to access the third node. There's only one gate, so we have to take the first node and then move to the second and then move to the third. So that is inefficient. However, the merit of the linked list is inserting and deleting is quite efficient. Okay, so today is the lecture.